accept the reality of the world with which we're presented. It's as simple as that.
It is as simple as that. Welcome, everybody, to GLOBEBUSTERS. We are on to, believe it or not, season number 9. Uh-oh, I don't remember the episode number. I'll find out quickly for you. Episode number 18, season 9, episode 18, and it is called the Michelson-Morely Experiment, with a little asterisk on experiment for now until we get to the end of the show. Hope everybody's doing well. We've got some panel members with us today. First, we've got Zack Zabala. Good times for all. Zack, what up?
Hey, Jeran, what's going on, man?
Another day, another fantastic show. So looking forward to it. And
yeah, me too.
We've got Alan from Space Audits. Alan, what's going on, my friend? You're on mute, probably.
Hey, what's going on, brother?
There we go. How are you? Thank you for being here.
Just
we appreciate it.
Can you hear me? Yeah.
If you guys aren't watching Space Audits, go there and subscribe now. You can go to the description in the YouTube video. Scroll down a little bit. You'll see it's the very first thing that pops up. You just click that little @Space Audits. It'll take you to his channel and become a subscriber. He's only got 639, but what he's doing is putting together these awesome presentations where he's learning the information for you and then presenting it in a compact form. But maybe it's not compact enough for some, because it's obviously detailed subjects. So you can get a condensed version, and you're even going to get a more condensed version today on the show. So awesome, Alan. Thanks for doing what you're doing. But I guess I wanted to ask you, what got you started? I don't know if people have actually heard about you yet. When did you get started in this arena? And what was it that brought you aboard?
So like when did I become like a flat earther, or when did I start making YouTube stuff?
Yeah, both.
So with flat earther, I started looking into the 7-Eleven situation, and I was like, okay, well, this turned out to be not what it was, and that was a big eye opener for me. And I always, was fascinated by space and science and all that. I always had a proclivity for it and liked it, and all that. And so I was into the moon landing and space travel and all that. And I started looking into the moon landing, and that turned out to be, I was like, oh man, they faked that one too. Dang, it's because like before it didn't even seem possible that something like that could be done until you realize, other deceptions that took place during your lifetime, and you're like, you just look back and you're like, oh yeah, they did it again.
Right.
So that was pretty eye-opening. And then I saw some flat Earth videos pop up in the recommended on YouTube, and I was like, okay, well, I'm going to debunk these because, I know about space and science. Like there has to be something real, right? So I go to debunk flat Earth, and here I am making flat Earth content now.
Never would
as the story goes.
Right. No, it's kind of, I mean, it's the story for all of us, really. I mean, I don't know anybody who just popped in there like, oh, I'm going to contribute to this. Even myself was a matter of, oh, if I start speaking about this stuff, somebody's going to step out and correct me and, prove to me where we live. And they, are still trying to do that and failing miserably. So, and then when did you start making videos? So that was how recent?
It's probably about like a year ago. I think it was whenever I'd messaged you about it, and I, dabbled in it a little bit. So what I started doing was making like response videos to YouTube comments, because what I would see in the comment sections on a lot of videos that were, space enthusiast propaganda type videos, there would be, the first comment was always, what would a flat earther say to this proof, and like that kind of stuff. So
right.
I was like, hey, this is what we would say, right? So I started kind of doing that kind of stuff, and then I just took it a step further. A lot of people were like, flat earthers don't read science papers. You guys don't understand math. You guys don't understand geometry. You guys are just bold with where's your science paper and all that stuff.
Mm-hmm.
So I was like, okay, cool. I'll read a couple science papers. So I started doing that, and I was like, oh, this is super interesting. And conveying that information and presenting it is just something that I've always been interested in. So I just I have fun doing it and learning it and teaching it. It's enjoyable for me. And like I get all excited when I find out something new and I can share it with everyone.
Yeah. Oh, well, that's probably one of the best things. What would you say is if you had to summarize what you've found? I know this can be very difficult, but summarize what you found in a couple sentences, 2 or 3 sentences. What have you seen in your studies of these papers?
So I've seen consistent evidence that the mainstream theory of interpretation of physics in the behavior of light, and that's in regards to the theory of relativity, the special and general theories respectively, is completely false, because there's tons of experimental evidence and technology based on the variance of the speed of light, and the way that they try and make allowances for the variance in the speed through the relative theories is just it doesn't hold up. And then when you look into the theories itself, it's just all logical. It's based on logical contradictions and things that leads to paradoxes, and then it's just abstract math. So
you
just see a lot of adherence to the abstract math.
Yeah, I mean, and then you can look at what Tesla said, that back in the day they had real scientists who thought clearly, and then all of a sudden now we've got this mathematics that it's all about the elegance of the math, and then they're able to basically plug things in, remove things, put placeholders, Lorentz transformations, you name it. You can adjust whatever you need to get it to come out looking like exactly what you've been wanting. So, to the layperson who sees science and they're like, well, everything works and everything, but what they don't see is the underlying tricks that have been placed. Even like having a special theory of relativity, then a general theory of relativity that contradict each other, but they use one or the other whenever they need it. It's like, well, how could that not be seen as fallacious? That's what's crazy to me.
It's a wonderful dance they've done.
Yeah, it's impressive. I mean, I'll definitely say it's impressive. But again, they've had a lot of time and a lot of the smartest men and mathematicians who had a goal, and they basically did what they needed to get that goal done. Let's start with something else. I just want to bring this up. I brought it up on my show, and I know people have been talking about it. So we're talking about the Taboo Conspiracy video that he put out that I still think is, let me reload this. I want to see if it's still unlisted. No, it's back up. Okay. So it was unlisted, and then he put it back up because I've been talking to him. And here's our issue with it. And I'm not saying that we're not wrong or that I'm not wrong. I could be. But what happened was he put out this video talking about a 36,000 mile per hour speed change. And here, we'll watch it from here.
Original video, unedited.
This is the rendezvous from above. We're coming down on the ATDA over the Indian Ocean. And so you really know you're moving. Here we're plunging down from above, and the ATDA is going across over the Indian Ocean. We've just passed the Sahara Desert. We're coming into...
So that one little motion that you just saw there is very peculiar to most of us because, again, picture this. You're going 18,000 miles per hour in a linear path, in a constant speed, consistent speed, and then all of a sudden you
over the Indian Ocean.
stop on
We've
a
just
dime.
passed the Sahara Desert. We're
Watch
coming
again.
into less than
Oops.
1,000
Go back
feet.
a little further.
Over the Indian Ocean, we're plunging down from above.
You
The
see that?
ATDA is going across.
So did the craft stop? What? Well, I guess somebody showed or talked to Taboo saying that they can see an angle change. So they're saying that the camera changed angle. So there's been, I talked to Craig about it. Craig says, oh no, it's because the camera's on an arm. There's all these different things, but basically I guess the consensus as of now is that whatever camera is attached to this craft here, the claim is that it's changing angle, causing the ground to stop below. So to me, what I did first is I said, okay, because I don't know if it was MC Toon. Somebody reached out to me and says, "Are you going to?" Oh no, it was actually FTFE. Says, "Are you going to remove your community guide or your community posts?" I'm like, "Which community post?" He said, "The other day you posted a link to Taboo's video and it's been debunked and he's pulled it, so you should pull your video." I'm like, "Oh, or pull your post." I'm like, "Okay, well let me go find out what's going on." So I was looking into it and I said, "Okay, I get what they're saying. If that is an angle change, then somebody should be able to recreate it." So by taking my phone and putting an item in view, kind of like that little craft there, and then walking forward, no matter what I could do, I could not change the angle such that it would render the ground to stop moving, right? So I'm moving across my garage floor with my camera pointing at the ground. Now I've got to change the angle while I continue to move forward and get the ground in the camera view to stop moving. And I couldn't get it. So I talked to Taboo last night and said, why don't you try and replicate it? If that's the reason you pulled the video because somebody claims that it's wrong or that, this is what happened, then they should be able to replicate that in video form. And so far, I just haven't seen it myself. Now, could be wrong. Maybe there's some way I can't figure out how to do it. But again, if you're walking, and maybe you guys could do this, and then if you figure out that we are wrong, please send me a message on Telegram, t.me/Jeranism. Yeah, just t.me/Jeranism. Again, we'll watch one more time here. You see it's flying 18, and then it just has to stop the ground from moving, and then it continues. So to me, even if you're going to say it's an angle change.
Wait a minute. I don't see the craft really change in the window.
It doesn't.
Like the amount of craft. Well, if the angle is changing on the camera, then the amount of craft in view should change as well.
I agree, and that was my original issue with the being pulled. But then what I've been told now is that the camera is attached to the craft. They're one. So now imagine that the entire craft is what's moving, right? So they're saying the craft is moving, causing the ground to move. Okay. So the problem with that, of course, is that to me, if you're flying 18,000 miles per hour and the ground is passing below you, and then you change your angle, causing the ground to stop, it almost like you'd have to match that perfectly. Like I can't even replicate it with my phone in my garage. I can't change the angle perfectly timed to my walk that causes the actual ground to stop moving, which is what happens here. So anyway, it's one of those things where we know NASA's faking things. We've seen a million things. This is just either another one or it's just something that we are thinking is probably faked, but it actually, they did it correctly. Now, when I say it did it correctly, I mean, I think that's a screen below them of some type. So it doesn't mean that it's still not being faked. It just means that this particular observation is not evidence of the fakery. If we can actually replicate it, then I'm like, okay, well, then we move on to something else. So maybe somebody out there can replicate it. But that's why Taboo has it back up. Does he have a post here? Let me see what he's got. 16 hours ago edited. Because there was a slight change of the angle, I unlisted the video. However, after speaking with Jeranism and after multiple tries, I cannot replicate the stopping of the Gemini craft at the speed with a slight change of angle. The Gemini craft does indeed appear to stop for at least a second. For now, you're welcome to reach your own conclusions. See if you can replicate the full Gemini stoppage with a slight angle change. I suggest someone try it as a passenger in a car. See if you can get the movement on the side of the car to come to a complete stop just by changing the angle. Right. So if you're showing your camera out the car window, you're driving straight on a freeway, is it possible to then slowly adjust the angle of the camera such that the outside stops moving in the frame of the camera? I'm not able to do that myself. So doesn't mean it can't be done, but just wanted to put that out there. That's why that is back up for now. Pretty incredible for them to be going 18,000 miles an hour and just do something like that. So that's one thing I wanted to bring up. The second thing I want to talk about is if you're interested in filming, we have about 5 people in the group, 6 people in the group that are going to be filming in the north, the sunset. And, I talked to Nathan. You guys know Nathan. Pitch Lumen is his name that comes on my show. But I was talking to Nathan yesterday, and he said, hey, I've got a better way for you to describe what's going on with the sun. And I thought he said it perfectly, and I was like, okay, that's great, because I was struggling to get this out. So here's the way you need to recognize what's going on with the sun, what we're noticing, what people are out there watching right now. Is in a globe Earth, you would have to have equal things in opposite seasons for the north and the south. That's kind of a requirement of the globe. There's really no way around that. They say half the year the north is tilted, half the year the south is tilted, and then you have the in-betweens. So you really shouldn't be able to see something glaring like what we're seeing. So here's what is happening. Because right now the sun is going out towards the Tropic of Capricorn, it is getting faster. Okay? For not just me, not just you, but everybody on Earth, the sun is getting faster. So what we're seeing right now is if everybody goes outside and they film the sunset, as soon as the sun disappears, if you start your camera, start your time clock, and you wait until the entire light of the sun has disappeared, that number for everyone on Earth is currently dropping. No matter where you're at, no matter where you film this, if you do it today and you do it in a week and you do it a week after that, you're going to notice that the amount of time, now you can call this twilight, it's kind of what it's always been called, but be careful because the globe does not consider twilight what we do. We consider it the light after the sun. The globe does it by math. So they say at 6 degrees below the horizon, this is twilight time. At 12 degrees, we call this twilight time. Well, what that does is it erases what we're finding. By doing it by degrees, it's going to work out. It's going to be the north and the south are the same on opposite seasons. But what's happening is the entire Earth is experiencing something at the same time. And after December 21st, when the sun starts working its way back towards the Tropic of Cancer, you're going to notice the opposite, meaning that everybody on Earth is then going to film the sunset, and the time length after the sunset, while the light is still there, is going to get longer. Why is that? Because the sun is getting slower. So it's that simple. On a globe, it would make it should be the opposite, meaning that when right now, since it's going towards their summer, the south should be getting longer time after the sun. And since we are going towards winter, we should get shorter time after the sun. That intuitively makes sense on a globe. And then the opposite is true come June. However, that's not what's happening. Both the north right now and the south right now are seeing the sun time go down. And that's because the sun is moving faster. And if the sun's moving faster, it's going to set, and then you're going to see the light dissipate faster and faster and faster because the sun's going faster and faster and faster. And then when we start coming back towards June, we're going to see the opposite. We're going to all see the amount of time after the sunset get longer, right? I hope I didn't say longer. I meant shorter going this way. But hopefully people get it, that because the sun is going faster, the amount of time that we see the sun is decreasing. So does that make sense? So if you are in...
I'm still seeing the YouTube.
What do you mean?
In the window.
Oh, sorry. I don't think I was showing anything. But I can...
Oh, okay. Alrighty.
I know people might be thinking I'm showing something. There we go. Put that up there for you. So hopefully that makes a little bit more sense and is a glaring problem. It's one of the, to me, one of the best things I've seen. And we're just trying to verify and make sure that nobody's making mistakes in their measurements or their timing. So if you are interested in joining the group, we have a Telegram group that's got 6 or 7 people in there, including the guy that's filming down south. It would be great if we got one more person to film down south. You don't need to film much. If you could film, 1 day a week for the next 3 weeks or 2 days a week for the next 3 weeks. All we're trying to verify is for you to come back and say, yes, for me in Detroit, I'm seeing the time after the sun sets decrease, right? You basically start a time clock as soon as you don't see the sun anymore. So it's gone now. Start the time clock and then keep watching that direction, and you're going to see the light of the sun. It's going to still be there. We all know that. And as it goes further and further away from us, slowly that light dissipates until there's a moment where you would be able to say, okay, I don't see any light from the sun anymore. Boom, stop your stopwatch. If you look at that, it's probably going to be, if you did it today in the north, somewhere around 50 minutes, maybe an hour, and then do it a week later. And what you're going to notice is that amount of time that you see the sun is decreasing, okay? Now, somebody in the south right now who does it, since they're getting close to their summer, should be doing the opposite. But guess what it's doing? It's decreasing. Why is that? Because the sun is moving faster for everyone on Earth. That is a fantastic evidence for a flat Earth, or at least something that's not a globe, because the globe doesn't have any mechanism that would ever explain how the sun is moving faster for everyone on Earth. It just doesn't work. So that's basically the proof that we're looking for there. And if you want to join us, just reach out to either me, t.me/Jeranism, or Austin, although he's busy moving right now, which is t.me/Witsit, WITSIT. And just say, hey, I want to help out with the filming. You don't even need, you could use your phone if you wanted to. You would just need a tripod, number one. It's not going to be good to hold it. You're going to be recording for like 2 hours. And a camera and some sort of battery setup where at least you can record for about 2 hours, which I think, the the P1000, P90, P900, I think that they all will record for about 2 hours. So you shouldn't really have a problem. I don't have anybody who's come back and said that it's been more than 2 hours that they see the light. So if you start recording basically when the sun hits the horizon and then stop it when you don't see the light anymore, you probably only need about an hour, maybe an hour 30 at the most to record that. But I wanted to ask, just as I explained it there, Zach, do you have any questions on that, or is that a better explanation?
No, that was good. I was just going to add, I was just looking up lumen meters. And like for $12 to $20, you can get one from, probably your local area. They sell them even at Walmart, it says. You can have one at least shipped there. But, they're sold all over. They do go way up in prices. They can get a lot more expensive. But I think if we had just something like that to where you could actually get a reading, a measurement, that's not just your optical opinion.
I agree. Although I do think that the optical opinion is going to be pretty definitive in the fact that,
oh yeah,
if the person, because I can go out and watch the sunset, and as long as I'm the one saying, okay, now I no longer see the sunlight, and then I record that time, and then a week later, it should be significantly different one way or the other. Either it's going to be, and I don't mean significantly, because we're probably talking about 1 or 2 minutes a week. Is what you're going to see difference, because basically what I've seen in the South, or what he's claimed, and I forgot the exact numbers. He got mad at me the other day for getting the numbers wrong. I think he started at like 125 or something, and he's down to like 105. So basically in June, you think you'd start there in the South, and you would start seeing it increase as you get closer to December. So right away we saw a problem that he messaged me and says, hey, why would it be going down? I'm like, wait, what? You're going down? I'm like, that doesn't, and then we kind of had to think about it, and then it, started to put things together. So I think it's one of those excellent things, and you can even go out and do it with your cell phone. Like I said, you want a tripod, you want to be able to have a clear view of something like horizon light. Now, some people have asked, can they do it if they've got mountains? Technically, yes, right? For instance, the sun sets behind the mountain, and you start your time clock there, and you keep watching until you don't see any remnant of the sun left, and then you do it again a week later. As long as it's the same setup, you don't want to move your camera, you don't want to be in a different location. And then the only thing you really have to decide is whether you're going to be judging when the light is gone based on your eyes or on the camera. Because
that might actually be easier to have the mountain range there, because you can just say, okay, when the background turns the same color as the mountain, that'll be my measuring stick.
Right. Yeah, I think so too. And I have a decent view. I think I'm going to do it myself. I found a place I can drive to and get a pretty good view of it, because I just want to verify for myself, because how could this be wrong? The only thing would be is if we are wrong in the north, because most of us are making the assumption that in the summer we get longer time after the sun sets. That should be, I think it's pretty obvious. And so imagine we've got something that's obvious for us here in the north that you would think, okay, well then it's obvious for them in the south in the opposite time, but it's not. We're actually all sharing that same.
That's wild.
That's wild. I mean, the fact that the north and the south are sharing the same time period, and the only thing that makes sense there is because in the summer for the north, the sun is in a very tight circle and it's going slow. And so everybody, even in the south, when the sun sets, they get an extended amount of time after the sun sets until they have no more light. Now, we in the north just take that as normal. In the south, though, they are seeing the same thing at the same time. So that's why it is wild. It is crazy. And it's going to be a real tough debunk. The only thing I could understand that the Globe will say is, well, you're just basing it like, basically what Zach was just saying. Oh, you're just basing it off your eye. You're just saying when, you're not actually measuring anything. This isn't proof of anything. However, we can all laugh at them as more and more people start filming and saying, no, I'm seeing the same thing. No matter where you're at on Earth right now. So as of today, no matter where you are on the Earth, your amount of time after the sun sets that you still see the light is decreasing. It's because we get closer to December, the sun is moving faster, and therefore it sets, and then it's off on its races. And so you're going to actually see blackness come after the sunset faster. So for us, in the summer, this is why the sun sets, 8:30 or so, here where I live in the height of summer, and it's not dark until 10. So we're getting that hour and a half after, and I just assumed, okay, well, in the South, they must be seeing the same thing, right? In the South, during their summer, which is we're getting closer to, they should have extended time after as well, but they don't. It's the opposite. So it's one of those things that if we can just get a few more people, reach out to me. We would like a good group of 10 or 15 of these, because if we get 15 people recording it and all 15 come back and say, for all of us, the number is decreasing week to week, we've got something that we can actually probably go, push pretty hard publicly, letters to institutions, things like.
And this makes sense. This is easy to comprehend right here.
I agree. It's intuitive to understand why it shouldn't be the way that it is. There's no reason why we would all experience the same thing at the same time on a globe Earth. We should be experiencing different things and opposite. And it's, so it should be easy to understand. Again, I thank Pitch Lumen for basically describing it in a way that I hadn't, which is simply everybody on Earth right now, the amount of time is going down. As soon as we hit December 21st, everybody on Earth, the amount of time will start creeping up. And that is not work in the globe. So,
no.
Alan, do you have any...
Oh, sorry.
No, go ahead.
I was just going to say there's a great comment over on Rockfin by Mike Westian talking about his security camera in his house. When the light gets so dark, it switches on to night vision.
Right.
I bet you could go through, and...
Mine does the same thing. I didn't even think about that.
Yeah, so as soon as it switches to night vision, there's your data point, your data set. And you could do it just by having a camera that's just recording all the time anyway. And I'm sure in the metadata somewhere on it, it tells you exactly when it switched over to night vision.
Yeah,
possibly.
There's and I like the idea of a meter. So, because I've never even seen one used. So what you're saying is you could point said meter at the sunset, and it would basically register the amount of light it's receiving. Yeah,
well. What it does, that meter, like a little meter, you could hold it up and just leave it even laying on the ground. And once it hits zero, no light, then you can mark that time down.
Okay, I'm going to look into them. So you're basically saying that it would know the moment it's not receiving any light from the sun. It would be like a definitive point. It wouldn't just like a gradient reduce.
I'm not 100%.
Yeah,
I've never played with one really.
Yeah, it's a good, but you're right. They are cheap. I've seen that. And Austin had mentioned that once we get past this initial stage of at least verifying these observations by having people, test it out, then we do need to look into that next step, which would be some sort of meter that we can show. But I think everyone knows who's in the north exactly what happens in our summer, which is we get more time after the sunset. And everybody knows in the winter, we get less time, meaning that the sun sets at 5:30 and it's dark by 6. I think everybody in the north knows that that's the truth. In the south, we just assume they must be seeing the same thing on the opposite season. But what we're finding out is they see the same thing at the same time, which, again, doesn't work on a globular Earth. Alan, just wanted to ask you if you have any questions on it or if it makes sense intuitively to you as well.
No, it makes sense, man. And the angle explanation that they give for it is really interesting. I didn't know that that's how they did it, but it makes perfect sense. If you were going to, if you're going to try and muddy the waters, it's exactly the way you would do it, right? So
yeah, no, that's the craziest thing is that I think when I went and looked at time and date and thought, okay, well, maybe because I tend to think they're not lying on time and date. That would be weird. You'd be able to pretty much easily show that if you're somebody who lives somewhere and you're like, hey, this thing's saying this time is when sunset is, but it doesn't happen for 15 minutes every day, or some sort of way of proving that. But so I tend to think that they show honest observations. So I wanted to see what the times were, and I can just show you that. I know I showed it last week, but when you go to time and date and let me show this for you guys, you would expect that it would show, I thought that it was going to show us the twilight times, and then basically we might be able to get something out of it. But what we learned is if we go down here to sunrise, sunset, and we are going to pick, we'll just pick Los Angeles and LA. Okay, so this is showing your different twilight times. So we've got nighttime, we've got astronomical twilight, we've got nautical twilight. So what we noticed is when we were looking back and forth between the same latitude, basically in the north and the south, well, we're noticing basically the same numbers at the same, and we're like, well, how is that the case? Well, it's because once you go down here and we look at what is twilight, dawn, and dusk, you'll notice that we think of it, and it even starts out by saying, twilight is the time between day and night when there is light outside, but the sun is below the horizon. So this is what we're measuring is the light outside, right? So we're technically measuring twilight. However, we'll see here, twilight occurs when the Earth's upper atmosphere scatters, refracts sunlight. A number of atmospheric phenomena or colors can be seen during twilight. Gives the 3 types of twilight. And then it says astronomers define. Oh, so the astronomers are going to define for us the 3 stages of twilight on the basis of how far the sun is below the horizon. So remember, if you've got a globe model, then the opposite is true in each different season, meaning that for the north in their summer and the south in their summer, that we would see basically the same numbers because they're calling it a sphere. They're saying the sun goes around or we spin. So to them, when you're talking about degree, that has nothing to do with light. Think about it. What they're claiming is it's how far the sun is below the horizon, but that doesn't tell us anything about light. If the sun is moving faster, for example, it's still 20 degrees below the horizon, but it's moving faster, and so we've already lost the light. So you can kind of see where they've confused everybody by this, by saying that civil twilight occurs when the sun is less than 6 degrees below the horizon. In the morning, civil twilight begins when the sun is 6 degrees below the horizon and ends at sunrise. So again, this is all mathematical, and it's a way of covering up what we're talking about now. So if you go to some professor and you say, hey, we're noticing that twilight, and they'll say, well, what do you mean? Twilight is at this moment in the north, and then it's at this moment in the south. Well, what they're basing that off of is the mathematics that give it 6 degrees below the horizon. Well, that's not what we're showing. We're showing the light, the actual real light, not numbers that you've come up with to hide this. And we see this a lot. I know Alan see it, I see it, where there's no explanation for this. It's, the things we talk about with the southern plane flights. You can believe that the southern plane flights prove the globe if you want, but you also have to believe then that it's proving planes fly 300 miles per hour in the south. Well, why would they do that? So there's lots of little things like this where it just keeps happening. Shout out to Bob. Bob, we miss you, by the way. The show we're trying, but it's not as good. But, Bob did a great job of always pointing out the preponderance of evidence, right? Because that's what was his big thing is that there's too many of these little things that keep knocking you in the back of the head for you to ignore it. And that's why I'm baffled by Globers who ignore this stuff is there's enough evidence that they should at least go, okay, now we need to actually think about this and not just be stupid, flat earthers, morons. We've been proving it for 2,000 years. Everything that they say is just, that's not debate. That's not conversation. That's just you shutting it down and basically protecting people that we're saying are lying to you. So wouldn't it be better to dig to the bottom and figure out that they are or aren't, not just assume because you were taught something in school that it must be true and therefore the people saying the opposite have alternative motives or grifting or whatever else you guys all say. So anyway, this is a way of hiding it, would be to change the idea of twilight to a simple mathematical formula rather than the actual amount of time that the sun remains after sunset, which is what people would want to know, right? If I went looking up right now, I wonder how long twilight is today, and I wanted to go see, well, this isn't really going to help me with the light that I see from the sun. This is just going to give me some arbitrary time that has nothing to do with light. It has only to do with how many degrees below the horizon do we say that the sun is, since we say it goes 360 degrees. And again, people get very confused by the sun moving faster, and they're always like, well, wouldn't we see that in the sky? No, because the sun moves 15 degrees per hour, period. That's just it. So whether I guess the way to describe this best is if you think of a bicycle tire and the spokes, and then you think of something that's sitting on the inner side of the spoke, so towards the center of the circle, and then think of let's say an ant. So an ant's on the inner side, and then an ant's at the outer edge of the spoke, and then the wheel's spinning. Well, is the ant on the outer edge, is he spinning faster than the ant on the inner edge? And the answer is yes. but are they both moving 15 degrees an hour? The answer is yes. So now you picture somebody living underneath that bicycle spoke, and they're looking up at like where you would see the sky, and they see it moving. Well, to them, they're only going to see that item moving in their sky 15 degrees an hour, even though it has a lot longer distance of going to go, so it moves faster. And then how would we see that? Well, the only time we would really be able to judge that is when the sun sets, watching the light that still comes from the sun and seeing how long that takes. So I think it's one of those excellent observations as long as we can get some more verification. So I would like another 1 or 2 people in the south for sure, and a few more in the north wouldn't hurt. So if you're interested in that, all you need is a camera or your phone, tripod, and some time and a view of the horizon. So that is all I think I had for you. Oh, I got one other thing. Starting on Tuesday, I've got a new show coming, which I thought I had. Oh, yeah, no, maybe I did. No, don't have it up. Let me see if I can see. Which I had a graphic for it, but I don't have it ready. So my problem is in a lot of these debates that people have, I tune out most of the time. Like let's say modern day debate. If we have a flat earth debate or something, usually they're like 4 hours, right? 4.5 hours, long time. People get stuck on certain subjects. I get frustrated. So I've always wanted a more succinct, compact debate show where basically you get to learn more, you get to see more, you get people to present things more. And so I've started the idea of using a time clock where you basically have a timed amount of time to discuss a certain topic and then you move on. And that's just to kind of keep the conversation moving. And then also...
That's how an actual debate works.
Right. Not like the ones that just sit around
like
and
the
look
real
back
ones.
and forth.
Yeah,
Right.
like in college and stuff like that. That's what they do. They get allotted amount of time and yeah.
Right. So my hope is that, and my guarantee to you will be, every debate will be under 1.5 hours total. And that's including what basically is going to happen is there's going to be an intro and then 3 questions each. So basically one side will be able to ask a question to the other side and the person will answer. That's going to take no longer than a minute or 2 per each question. And then we'll get into the topics, and the topics, there'll be 6 for each person, meaning each person is bringing to the table 6 things they want to discuss. And they basically are going to, you can decide between yourselves whether you want to actually inform the person ahead of time or not. I'm assuming we'll have both. Sometimes people will say, no, I want to do it blind, meaning they're going in with some gotchas and they may be gotten with some gotchas because both people are going to go in not knowing the other person's 6 topics. So far, in the debates I've done and the one that we've already got scheduled for this coming Tuesday, both people have shared the topics. So right now, if you, let me get this up here. So we have on Tuesday at 6 p.m. Pacific, we've got MC Toon going against Brian Leakey. And there we go. It's called Debatism. So that'll be Tuesday at 6 p.m. Pacific. They both have the topics already. So basically, they'll each give a quick 2-minute intro. They'll each have 3 questions for each other that they already know. They've already been informed of the questions or already getting the answers together. And then they already know the other person's 6 topics. So what this does is it kind of speeds up the debate in a way everybody knows what's coming as far as each of them. They can have their presentation ready to go. And basically, we are going to do those questions, like I said, 1 or 2 minutes each. Then the topics are going to be timed at 5 minutes each. Maybe I'll add a minute if I think the conversation is good. But for the most part, at 5 minutes, we will stop that clock, stop the conversation on that topic, and move to the next one. So with each person bringing 6, that gives a total of 12 topics that will be discussed, plus the 3 questions answered for each, which is a total of 6 questions, plus an intro, plus an outro, plus answering questions from the chat, all done in a tidy little bowl, tidy little package in an hour and a half. And if I can get that down to an hour, which would be ideal, but I like the idea of 6 topics. I like the idea of 12 topics. So what you get, and I've already seen the topics for this debate, and it's going to be great because I already see what the 6 or the 12 topics are. They're all very relevant. Each person's going to, and then it's an open conversation pretty much. If I have to butt in and moderate and say, stop it. Now, you have 2 minutes, go. You have 2 minutes, go. I'll do that. But the hope is that for those 5 minutes, it's basically somebody presenting a topic, saying their claim on it, and then the other person countering that claim. And so by the end of these debates, you should at least have a better idea of those 12 topics, which person presented their side of the story better. And I think that that's kind of what I'm looking for. It's a more compact, complete debate than I've seen anywhere else. So that's what I'm trying for. Again, that starts Tuesday, 6 p.m. If you're interested in debating on the show, you can do one of two things. Either one, message me, t.me/Jeranism. I've already had 3 or 4 people do this who say, I want to debate X topic, and it could be anything. It doesn't have to be flat Earth. If you want to debate evolution, you want to debate Christianity, you want to debate Hinduism, whatever. Just tell me the topic and say I'm open to any opponent. And then what I'm going to do, and I haven't done this yet, but is create a page on my website that basically lists the open opportunities or the people that are open to debate such topics. So maybe somebody's dinosaurs are fake, and they're waiting for an opponent. So you'll be able to go there and say, oh, I want to go against that person. Or you can message me and say you already have an opponent, which is fine by me. If you've already talked to somebody and you've decided between yourselves to bring it to the stage here, then just message me and say, hey, Tony and I want to debate. He's taking this position. I'm taking this position. When's the next available show? And I'll check the calendar and get you guys a date. And from there, you guys just need to decide whether you're going to share topics or play in the dark. And so, like I said, this coming Tuesday will be the first episode, 6 p.m. Pacific. Brian against MC Toon, and both of them already have their topics and questions. So that should be fun. All right. Sorry to take so much of your time, Alan. I want to talk Michelson-Morely because there is a group around these parts that for some reason can't grasp it. They think that it doesn't occur in the natural world, so what difference does it make or something? And that's just crazy. If we as human beings can create measuring devices, measuring tools, and it's okay to use those, just like this meter that we're talking about using for these sunsets, just like you use a ruler, just like anything that you use to measure is a man-made device, and that's okay. So we can't just say we cannot use man-made devices in experiments. That's ridiculous. And if what you're testing shows something that needs to be explained, well, that's where you start getting the science behind it. And there's a group out there saying that things aren't experiments unless they meet strict criteria. And we might be surprised when we learn whether or not this one meets that strict criteria. So I'll let you go, Alan, if you want to preface it with anything other than what I just said. But I think Michelson-Morely, there's a reason it is the most famous experiment. I guess they call it the most famous failed experiment, but I can't really think of one that's more famous that is out there. There's a reason for that. And there's a group out there who thinks that somehow this is globe proof or globe evidence or something like that. And it's really not. When you know what happened, what they had to do, what they were looking for, what they saw, what they had to change in order to make up for what they saw. And then you get into the Dayton Miller stuff, which I hope we talk about a little bit today. But, there's a Dayton Miller guy who's done 5 million measurements using interferometry of the speed of light. Basically, it's the speed of light, but it's how light propagates in various directions. And what they're noticing is, remember, relativity says that the speed of light is the same for all observers regardless. And what they're finding is that's not true. There is a preferred direction. And what that means, again, many people might jump to the conclusion, it means that we're spinning or we're traveling here or we're doing these. But the speeds are way less than traveling around the sun, and they're not picking up any other travel around the galaxy or around the Great Attractor. And so you can tend to lean back and say, well, wait, could this be them measuring the ether or the ether wind or anything like that? And the answer is, well, of course, because we're finding out that those speeds are dependent on the season and they're dependent on the altitude, which does not work on a globe. There's no reason why the globe would not have a different speed because of altitude or because of the season. And so we're finding, so this is something that all flat earthers, in my opinion, should know, even without the Dayton Miller stuff. They should know about Michelson-Morley because it changed physics. Everything that we have today, relativity, space-time, general, special, Lorentz transformations, all these things are a result of a test that they thought they were going to be able to show an ether, and then they didn't get one. So they just said, the ether doesn't exist. And is that the right, assumption? Well, we're going to find out as Alan has done extensive research into this and come up with a little presentation. So Alan, whenever you want to go, it's all you.
Yeah, absolutely. I have the screen share started.
Thank you.
But before we begin, I want to say I'm excited for the Debatism show, man. I'm really looking forward to it. The exact structure and format that you thought of and laid out is exactly what I was wanting to see in a debate, because like you were saying, like modern day debates, it's cool that they have a platform for people to, hash all that stuff out or whatever, but it's very lackluster in terms of like actual structure, actually getting two people to convey ideas about the subject matter that they're talking about, and in terms of being prepared and stuff. So I think it'll be really interesting and an elevated contribution to the overall discussion.
Yeah, and I'm not somebody who shies. Yeah, I'm not somebody who shies away from hearing the other side, because if you're really looking for the truth, then you have to hear your opponent's position. Now, a lot of us know the globe better than globe believers, even.
Yep.
But it's still okay to hear them out. And just because somebody presents something that makes you think or makes you have to go back to the drawing board, that's part of growing. That's part. I see too much people who just dig their feet in and basically say, "Okay, we're done. We're done now. We'll just sit here and do this." And that's not being intellectually honest. You're not allowing the other side. And this is what we've been so upset about, right? When we talk about the flat earth, it's like, oh, well, the globe earth just sits there and they won't even hear it out. Well, we just go and do the opposite. We do the same thing. And so I don't think that's very intellectually honest. I don't mind hearing people out. And I think the more I hear these guys out, the more sometimes I realize they don't know. So I want people to talk. Yeah. I want people to bring up these conversations. And if something of flat earth that we all believe gets debunked or gets torn apart, then that's a good thing, because it means we go back to the drawing board and we figure some stuff out that we didn't otherwise know. So thanks. I think it's going to be good. And you're right. I think I want to hear people, rather than fight each other too, right? It shouldn't be a fight. And this is not a place for a fight, because you don't have enough time. I'm going to be moving to the next subject. You're going to have a new topic to talk about. So any fight is going to quickly be kind of extinguished, and we'll move on. And I think that I can do a good job of moderating that way, because I know what I'm looking for out of the show, right? I want information. I want 12 topics. I want 12 claims or counterclaims. And if it starts going off the rails somewhere else, then I'm just going to stop it and bring it back and say, that's not the point of the show. You're not going in the right direction. We need to learn about these topics, these 12 things you've already said you're going to talk about, and you only have 5 minutes, so you better make your argument succinct and compact. Otherwise, you're just going to look like you were bumbling the whole time. So, all right, you are on the screen and I believe ready to go.
All right, cool.
I'll stop you if I have any questions too.
Okay, yeah. So that was a great preface that you gave to Michelson-Morely and the historicity of the experiment and its significance and the role in mainstream physics. Because after this experiment, after this null result, so-called, all of physics was redefined to compensate for this experiment, so that the validity of heliocentrism wouldn't be in question. We'll get more into that as we go through. So the title of the presentation is the Michelson-Morley experiment, demonstration, experiment, or parlor trick. We're going to get into the scientific method a little bit and what is an experiment, that sort of stuff real quick. So the scientific method, what it is and what it isn't. So it's not a formula and it's not magic. So you can't just use abstract math to explain everything, and it's not a magic solution to everything. It's an ever-evolving progression towards the truth, and that's what this section down here kind of reiterates. You're looking for is a cause and effect relationship with phenomenon, and you're doing experiments to isolate that cause and effect relationship and narrow down your explanation as to that phenomenon, underlying principles of what's causing it, right? And there's some definitions that to define, to set by, so we all know that we're speaking the same language here. So a hypothesis is a statement that's made by a researcher that is a working assumption that is
Hold on 1 second, real quick. Sorry, Alan. You're
Same
roboting.
for me.
Yeah, you're roboting. I'm going to actually shut down my video so I'm not adding to the bandwidth. Let me do that real quick. I don't think you don't have your camera on or anything, right?
No.
Okay. And Zach, you don't have anything on? How do I turn this off?
No.
I'll do it from OBS. Let me do it from here. Let me stop my virtual camera. Okay, so now you just see my logo, right?
Yeah.
Okay.
The OBS logo.
OBS logo.
Oh, I wonder if I need to turn that off. Why is that? So I see turn video off. There we go. Now you see my logo.
Yeah.
Okay, well, that's probably the cleanest we can get it. So hopefully it comes in a little clearer. If not, we'll have you drop out and come back, but we'll see how it goes for now.
All right. Yeah. How's it sound now? Is it clear?
Right now it's a little better.
Shoot. All right. Sorry about that. Yeah, it's just my internet's just the time of day. So for the definitions, hypothesis, this is a statement that's made by a researcher that is a working assumption that is something that you assume to be true, so you can test it for the purpose of the investigation. An example of that might be the Earth is round. Using that as a working hypothesis to test your theory. So the theory, the general principles that are drawn from the event and make predictions about the event that you're trying to explain, and falsify a falsifiable and null hypothesis. So this is your hypothesis has to be something that can be false. It's not something that you can just, they can't just make an unfalsifiable claim. So that's kind of the framework that we're looking at here. So how's it sound now? Is it better?
I think what I'm going to do, you can keep going, but I might open up a Zoom and just see if Zoom, because we'll be able to tell right away, is Zoom better than Skype? Maybe it's Skype that's slowing it down, and Zoom would pick it up better.
It seems like when you speak a little faster, it really starts dubbing itself over itself. But when you were at the end there, when you were speaking a little slower, I could understand it a lot clearer. I am getting every word though, every word.
All right, let me reset my internet real quick.
Okay, I'm going to open up a Zoom just to see if that's easier.
Okay,
I think
cool.
Zoom should be
send
better
me the
than
Zoom
Skype.
thing on.
What do you
Skype,
do
and
when
I'll
you do your shows with other people? Are you usually on Zoom or Discord?
Discord.
Okay, because usually I don't hear that from you. I don't really hear that breakup. So
I'm usually on it later in the day, but yeah, I'll reset real quick and we'll get back to this. So I'll be right back.
I'm going to send you the link too on Telegram.
Okay.
So just give me 1 second. We're going to schedule a meeting, and we can do 4. Talk amongst yourselves. I'll give you a topic. Michelson-Morely, experiment or not? Discuss. All right, now let me get this going. All right, we've got 2 hours. That's fine. Today is the 10th. Yes, okay. Let's go save. And you know how to get on Zoom, yeah? Obviously, Zach. I'm gonna send you this link.
Yeah.
I'll probably shut down Skype for the rest of the day. Copy link address. Okay, I'm gonna send this to you in chat. And guys, we will be right back. Do I have a commercial we could play? I think I do. Let me see. Got something here. What do we have over here? I thought I had Weiss's. We'll play this real quick. It's JJ's CBDrub.com, a commercial for you. We'll be right back, and don't go anywhere.
Take your muscle and joint aches away with JJ's. Text CBD to 920-382-7720 for $50 off a 3-pack of amazing JJ's Natural CBD Rub and or a 3-pack of 3,000 milligram CBD veggie capsules, 100 count. Best balm and capsules on the plain earth. Made organic with bee's knees strain hemp, extracted with dry ice bubble hash method, so never any harmful solvents. Check out our testimonials. Visit jjcbdrub.com.
Hi, I'm Neil Belson, your NASA administrator, so check yourself, bitch. 2023 is shaping up to be tremendous here at NASA. But we do need more money. Your donation will make you an immediate 33rd degree Mason. And that means you can wear an apron and hide secrets like we do, and that's really cool. Yes, we do fake everything we show you, but retards believe it, and so we will continue stealing money and presenting you with CGI. But we also will be providing you with an inclusive and a diverse staff. We are never going to stop fondling your imagination and reaching you in your unreachable parts. And we will do it bigger, faster, and harder than ever before. Thanks to the money we steal daily, we're committed to going to the stars in just 8 more years. Remember to buy Bitcoin. Did I mention that aero-arousal technology to probe space is right around the corner? And you should sign up soon. No, not for my secret society, the Book of the Snake. That's a Yale secret, and you're just a crappy citizen, and we here at NASA owe you nothing. Did we mention we could use some more money for our budget? But you too can be a part of the NASA team. Just be African American or female or trans. In fact, you can even identify as gravity, and you're in. Easy peasy. Eat your sugar pops, drink your fluoridated water, and study physics at any university. We know you can't get enough of our Fartimus. Fartimus has never been so engulfing as it is here at NASA. If you're wondering how old I am, the answer is 197. I am so old I fart dust. Or as we say here at the Cape, I fartimus dust. If you're also wondering who told me to lie to you and the world, it was my father, Satan. Now, the main question on everyone's mind is who should be sent to your anus first? Which African American should plant the anti-white privilege flag on the surface of the moon, which, by the way, we will now color black or rainbow? The moon can no longer be white. Clearly, it is a white as a result of the original paternal layout for the white man to inflict harm on his poor black brother. Just ask Lyndon B. Johnson. Also, the moon is being renamed as of today. It is now called the Rock-Hard George Floyd. At NASA, you will learn the health benefits of adrenochrome. You'll learn that we like children and chocolate ice cream. You will also learn...
Thank you, Bill Nelson. That was very nice of you. All right, let's see if everything's better. Alan, go ahead and share your screen if you want, and we will see if we fix it.
Cool, hopefully.
That'd be nice. I know Austin wants us to move to Telegram. He says that the sharing there is a lot better too, so let's see.
Where did you get that commercial? That was hilarious.
I made that. We use the voice thing to
Do you just type it into something and the voice does it automatic, or is it like
you have to clone his,
and it changes it?
No, you got to clone his voice and then you just enter the text. We actually did that together live on one of my shows, where all the people in the chat were the ones throwing the one-liners out. So that's why I kind of was all over the place, because it's just random people saying things in chat and then just adding it to the story.
It's almost funnier that way.
It is funny.
Because it catches you off guard.
It just
really
out of nowhere just pulls it, buy Bitcoin. Yeah. Like what?
All right, how does that look?
Looks good.
Okay.
Sounds good. Let's see if we fixed it. I don't have high hopes, because usually when stuff like this, it doesn't work as I think it will. But yes, your screen is showing. Go right ahead.
Okay, cool. So backing up a little bit to the see where we leave off. So going through the scientific method, the processes of experiments and all that. So we got step 1, make an observation. Step 2, define the problem. Step 3, form a hypothesis. Step 4, conduct an experiment. And step 5, derive a theory based on all your cumulative evidence and data from your experiments. And then the most important step, in my opinion, is replication of that experiment. So other people should be able to replicate your results. So in the case of Michelson-Morely, we're going to get into, was that result repeated? And we'll learn about that as we go along. So following that that method, that framework of the scientific method, we're going to take a look. We're going to examine heliocentrism and geocentrism and see if there's an experiment that could be formed to differentiate between the two models. So step 1, observation. Throughout the course of a year, the stars we see in the night sky change every 6 months. Is the Earth in motion with the celestial bodies, or is the Earth at rest with respect to the celestial bodies? Step 2, defining the problem. Is the sky moving, or are we moving with the sky? From our terrestrial perspective and models based solely on observations, i.e. calculative models based on reoccurring cycles, there's no way to differentiate between the correctness of the axioms of heliocentrism and the axioms of geocentrism with respect to the rotation of the sky. And the biggest axiom, of course, for heliocentrism would be that it requires that the Earth is also in motion, right? So that's like the big difference there between the two models in terms of the axioms. So a geocentric would be a stationary Earth, and heliocentrism was based on an Earth that's in motion. So those are the two models of what we see in the sky, and that's so the interpretations that they put forward. So is the audio still good?
So far, so good.
Awesome. Okay, so we're gonna look at some heliocentric and geocentric models here. So for heliocentrism, you would have an Earth orbiting around the sun, changing position. So the sun would be blocking the star view in this direction. So people making observations at nighttime would be seeing this set of stars, at a particular time of the year. And then 6 months later, when the sun is blocking that side and they're looking on an opposite side, they're looking at a different set of stars. And as the Earth is going around in its circular orbit or elliptical and or geodesic, depending on which belief system you adhere to, you'll see different stars based on that. That's the interpretation for heliocentrism. So here we have a nice visual layout of our solar system. We got the sun here at the center, the Earth going in a circle. Everything is going in a circle. Very cool. And then for the geocentric models, we have a stationary Earth here in the center and everything going around us. And you see these little curve patterns where it comes in and starts to go in and backwards and stuff. And those are to explain retrograde motions and things like that. So when you map out all the motions of the wandering stars and all that with the geocentric model, you'll start to get what appear to be like fractal geometry patterns and geometric shapes of what it looks like, a holographic projection of a magnet, which we'll look at here later. We'll blaze through some of these and just look at the models real quick, and just so you guys can see what we're talking about here. So these are, this is what the orbital paths look like when plotted on a geocentric model. This is what it would look like overhead, if you were to see it.
And we've known this for supposedly thousands of years. I mean, Ptolemy has a chart that shows a lot of these. I think it's just the 5 planets, though.
Yeah.
What's crazy too, I don't know if you've heard this, Alan. Did you know that Copernicus's system had more epicycles?
Yeah, they claim that Tycho's had more, whatever, but then it turns out it's the opposite. Yeah.
Of course.
It's a mess, man. And then they do this whole thing where they're like, well, the mathematical elegance, and it's much simpler. And it's like, according to who, man?
Right.
So,
well, again, it's the same thing as them basically saying, oh, well, all observations so we're the center of the Earth, so let's make up a theory about raisin bread and that we're all on these raisin breads. And then they just went in that direction. It's like, well, that's not, you didn't put equal opportunity on both options. You said, one, we have to stay away from the absolute horror of that one. And then you went in the other direction, and people all think, oh yeah, science is on the up and up. Sure.
Yeah, absolutely. So here's just some more celestial observations plotted over a stationary plane. This is the eclipse cycles. So this is just a quick video. There's no audio required, so I'll just play through a little bit. This is just a ferrocell and a magnet in the hologram projection. So you'll see a lot of the same patterns that the wandering stars make. And this is just more of that. This one is the, what was that? That was the projection of the sun plotted at every latitude for an observer by FE Core. Shoot, hit the wrong button.
Yeah, that blew my mind.
This one right here. Yeah. So
toroid.
Yeah, dude. So showing that the sun's not a physical object and where it would be located to an observer relative at every latitude. And then when you plot it around a globe, it makes this fractal toroidal pattern. It's very cool. Yeah, so that's what that is. And to close out on the orbital stuff, just one more time, we got some orbital paths of so Venus, Mars, Jupiter, and Saturn. So to explain their motions, you'll get those fractal patterns that looks very much like a magnetic toroid and all that stuff. Very cool. So here's one more. Same thing over a plane and the orbits and how they look following magnetic flux lines. All right, so hypothesis. If heliocentrism were true based on the yearly cycles, the Earth is required to be in motion at a certain speed. That speed is 30 kilometers a second to be precise, in combination with the current understanding of electromagnetic theory, which is based on a stationary ether that carries a charge potential for an accelerating electric field to generate a magnetic field. And with that background medium to carry the charge potential of the electric and magnetic field induction, there's that will also affect electromagnetic propagation in the form of resistance to the speed of C, to the speed of electromagnetic propagation if you're in motion relative to that ether. So with that understanding of the rate of induction of C from Maxwell's equations and the etheric framework to provide a mechanism for the variance of C, Earth's orbital velocity should be revealed in the form of a fringe shift pattern. The variance of C should produce a fringe shift pattern corresponding to the resistance that the ether would have on a light beam that's perpendicular to the direction of motion around the sun at 30 kilometers a second. So imagine you're driving down the highway and you stick your arm out the car window. Your arm will experience air resistance relative to how fast you're traveling through it. So for the hypothesis of this, of the two models, or the three models really, because this test, the way that it's framed is that this test was an experiment of the ether and that it disproved the ether and all these things. That's not that's not true. The test was twofold. It was a test of Earth's motion and a stationary ether. Now, all the old ether frameworks that were put forward were, by the old physicists and mathematicians, were done to explain various phenomenons a different way. So they fail at different levels explaining other phenomenon. And of course, their underlying and framework of interpretation was adherence to the Copernican principle. So their question of how the ether worked and the Earth's relationship to it in regards to motion was that the ether was stationary, and that their interpretation of the ether wind effect was that because of the Earth rotating through the stationary ether, there's a ether wind effect. So when you're reading the old papers of how they describe an ether wind, that's the way that they're talking about it. And the way that I'll be talking about it, it's a stationary Earth with respect to an ether wind. So let's see here. So for heliocentrism, in this experiment, in the Michelson-Morely experiment, that they're going to do. So affirmation of heliocentrism would be 5 fringe shift patterns. A null result would be no fringe shift patterns, meaning that the speed of light can't be used to measure motion in this way. And that's the explanation that they ultimately ended up trying to go with. So falsified would be a slight fringe shift pattern that's repeatable and persists. So it's outside of the error tolerance means and all that. And for geocentrism to be affirmed, there would be a slight fringe shift pattern that's reproducible outside of error tolerances. So a null result would be no fringe shift pattern, and falsification would be 5 fringes. So that would be positive evidence for heliocentrism if there were 5 fringes. And for a stationary ether framework, the affirmation would be slight fringes that are reproducible outside of error tolerance. The null would be slight fringes within error tolerance, and falsified would be no fringe pattern, meaning that the speed of light is the same and it doesn't produce any patterns when it recombines at the end when it hits the photographic plate. So moving forward, Michelson and his boy Morley came up with the way to test this. They came up
That's
with
not his name, by the way. There's some people in charge of debate channels that ask the question, Michelson-Morely, is that a guy? No, it's 2 guys. But go ahead. Yep,
Albert Michelson and Edward Morley. So these 2 gentlemen came up with a way to test this hypothesis, or these various hypotheses. So what they have here is a concrete slab over a vat of mercury that's held up by a wooden table or a wooden slab that's floating in the vat of mercury. So what they can do with this is they could rotate and orientate the device however they need to align it such that the one of the axes of the arms will be perpendicular to the axis of motion of Earth's orbital velocity and all that, so to get it lined up, and it reduces vibrations and all that. So anyway, what they got going on here is they shoot a coherent beam of light through a prism, and it splits, hits these reflective mirrors, bounces back and forth until it hits the beam recombiner, and it hits a photographic plate, and they take their measurement, right? And that's where they get their fringe shift patterns. So the idea here is that if there's a variance in the speed of light caused by Earth's motion, that light is going to be traveling slower as it goes along as it's traveling along the direction of one of these mirrors, right? That's aligned with Earth's orbital velocity, or perpendicular to that, rather. So, any questions?
Not so far. No, good.
Okay, cool. So for experimental variables, in an experiment, it's important to have your independence, your controls, and dependence and such. So we'll go over that in the Michelson-Morley experiment. So the independent variable would be the orientation of the interferometer with respect to Earth's direction of orbit. The apparatus was aligned such that it was perpendicular, that the perpendicular arm of the apparatus was to the direction of motion of Earth's orbital velocities, and that would, cause a resistance in C, which the variance would show a fringe shift pattern. So changing the orientation of the apparatus and observing the fringes will allow you to interpret the results and establish a cause and effect relationship with why there's a variance, why there's a fringe shift pattern, right, in the first place. So interpretations of the result regarding the hypothesis to detect Earth motion would be 5 fringes equals 5 fringes at 5 kilometers a second would be positive evidence for heliocentrism. No fringes would be that C is invariant with respect to motion of the source or observer, and then in combination with that understanding, you could come up with a framework to provide positive evidence for heliocentrism, and that's what they did with the special theory of relativity. And then a slight fringe would be a stationary Earth with respect to an ether wind, positive evidence against heliocentrism. So experimental variables defined. The dependent variable, the dependent would be a fringe shift pattern produced that is dependent on Earth's assumed motion through a stationary or moving ether. And the strength of the readings at various times a day will help establish a cause and effect relationship. Is it truly Earth and being in motion? Because at certain times of day, with the Earth rotating as well, the interferometer is going to be out of alignment with Earth's with that orbital motion, so it's not going to get as strong of a reading and stuff. So changing, just taking the readings at different times of day will allow you to establish that relationship. Will help establish that. So for the controls, we have vibrations in the environment, in the nearby area. So by mounting the apparatus in a mercury vat so that it floats nice and level, and it's independent of the like vibrations and stuff from nearby. And then we have additional mirrors were added to the apparatus to increase the length that light has to travel. So this allowed them to get stronger readings by increasing the effect that the ether would that the ether resistance would have on the propagation, and taking different readings at different times to isolate the cause and effect relationship. So again, like I was saying, with the rotation of the Earth being aligned at certain times of day with the direction of motion. So here's a topographical view of that concrete slab in the apparatus where everything was mounted, and you can see the path of light and what happened with it and how it hits all these reflections and bounces back and then recombines. And then they look here for their interference pattern. So we have their data set that they provided in the Michelson-Morely experiment. So these are their readings on the days and the different times that they took the readings. We have the dotted line here, which is what they predicted that their fringe shift pattern should get for positive evidence for heliocentrism. And then the solid line is the actual readings that they got. So they got just over one fringe. So their interpretation is that they got a reading of 5.5 to 6 kilometers a second. So following the scientific method that we listed earlier, step 5 would be conclusion and deriving a theory based on the evidence, right? So experimental results of the fringe shift produced was 1/6 to 1/8 of that is required to provide a positive first order measurement of Earth's orbital velocity. Theory 1 for heliocentrism, attributing the slight fringe to instrumental air and using postulates based on the invariance of C regarding the source of motion, or regarding motion in the source of light and the observer. A mathematical framework can be used to interpret the lack of fringes using an ether framework or later special relativity through second order corrections, being time dilation and length contraction. And then under this new framework, the established invariance of C can be used as the mechanism. So you can say that the slight fringe that was produced was due to length contraction and time dilation, and you can extract that through second order corrections of the coordinate system transformation to say that the amount that it contracted by was the exact amount needed to provide the full reading to confirm heliocentrism. Right? So note, in relativity theory, an observer outside of Earth's reference frame should not or would not see a fringe shift pattern if they could observe the Michelson-Morely experiment being conducted on Earth. So that's their interpretation with reference frames and how it works. So they say that in our reference frame, we measured a slight fringe, and that was due to length contraction. And that normally there wouldn't be any fringe, but the amount that we get, if you apply the correction factor to it, you would get 30 kilometers a second. And that's that's what they came up with special relativity. And that theory, that framework mathematically is actually based on Lorentz's ether theory and framework, and it adheres entirely to Lorentz covariance and all that. So the only difference between these two theories, between an ether theory and space-time, is that Einstein said that the ether is unnecessary to provide the mechanism of contraction, and that if we add a fourth axis, that being time, we can contract time and space hyperbolically to to conform to C and establish that Lorentz correction. So like that's what that's all about, is establishing that fourth axis and then contracting space and time hyperbolically such that they contract to meet C, so that they can say that it's invariant in all reference frames. So conclusions and deriving a theory. So this would be for the geocentric side of things. So the Earth is stationary with respect to an ether wind that follows the sidereal rotation of the sky. Note that no second order corrections, i.e. length contraction or time dilation or postulates, are required for this interpretation. Normally, a first order measurement corresponding to a viable hypothesis is the favored interpretation, as it is the highest form of evidence that can be provided by an experimental result. But for some reason, they decided to, not go with that. So in terms of replicating Michelson-Morely and the ether and all that, and falsifying the framework of interpretation that was put forward to explain these results and save Earth's orbital velocity that was shown not to be true, we'll look at the history of interferometry. So starting with Michelson-Morely in 1887, and then we have Sagnac in 1993, Michelson-Gale in 1925, Dayton Miller from 1905 to 1925, and then he republished all of his work with a summary and all that in 1930. He's the guy that did 5,200,000 measurements. We have Pruner and Dufour in 1942 who reproduced the Michelson-Morley experiment. And then we have, Yuri Galev, who reproduced Dayton Miller's work using millimeter radio wave propagation. And then he also did it in 2002 using optical wave bands. And then we have Ruyong Wang, who linearized the Sagnac effect in 2004, which we'll get into. And we have Manera in 2006, who used a classic Michelson-Morley interferometer setup and left it running for 3 years. And the culmination of all that data backed up Miller's findings as well. So we'll get into the quick details of all these experiments real quick. So we already covered Michelson-Morley earlier with the predicted fringe shifts and what they actually measured. And this is just going over the control variables. So putting it in a vat of mercury and all that, and taking the readings at a different time of day to establish a cause and effect relationship with the variance of electromagnetic propagation. So let's see. So for Sagnac, so for his interferometer, he and I don't have a graphic for it, I'm sorry, but it's just a circular interferometer. So just imagine the Michelson-Morley device set up in a triangle or a square. It doesn't matter, with 3 mirrors or 4, doesn't matter. But then just the only difference is that the device is rotating constantly while they're taking the readings. And they say that the difference there is that because it's a rotating device, it's a non-inertial reference frame, so special relativity doesn't apply, and the relativistic effects, it doesn't falsify special relativity in that regard. And then in 1918, Paul Lavue and a couple other guys came up with a special metric tensor in the general theory of relativity to describe the conservation laws on the small scale. So they say for a small rotating device, the energy of that is equivalent to what would be required to generate little pockets of time dilation and length contraction. So a rotating device is actually dilating time and length and contracting time such that it allows for this variance in speed. So that's the way they explain it with the general theory. And of course, through the equivalence principle, where motion and gravitation, acceleration and gravitation are linked, equivalent and all that, mass and energy, the two theories are mathematically, joined or whatever. So it's still, so they ended up co-opting this experiment and effect in the relativistic means, but they attribute it explicitly to angular rotation, which will be important moving forward. That explanation of how they co-opted this effect. So for Michelson-Gale, they have a stationary rectangle interferometer that they built into the ground. It has vacuum. They vacuumed out the tubes, and they got readings that show a varying speed of light. For the mathematic framework of the analysis that they used to interpret their results, they used a stationary ether framework, and what that means is they used a fixed reference frame to measure the relative velocity of electromagnetic propagation in the pipes facing east and west, and the pipes and the difference of the ones facing north and south. So you can see that here in the equation. This is the east-west and the north-south one here. And and that's the framework that they use. Now they have a special note in the paper here where they say that it's all in accordance with relativity and it's all good. But relativity theory is based on second order corrections and not first order corrections. So this interpretation here is a first order measurement because it's not correcting for any, it's not saying anything's contracting or anything like that. It's not changing
They
reference
really
frames.
jumped through a lot of loops, didn't they, to
Yes.
put this all together the way they have it. With, I mean, special relativity is such a joke, but it's hoodwinked some really intelligent people.
Yeah.
It's amazing.
It's amazing, man. And you can't go against it. And the way that they have it reified through the equivalence principle and all that, it's like you can't really separate the theories. So like, say you're like a really, say you see the discrepancies in the theories and whatnot, and you try, you want to critique it. It's like, well, if you critique one, you're going to body bag the other one because they're not separable. Right. So, yeah, you don't see like much resistance to it in that regard. Like, once people adhere to it, it's pretty much a wrap.
Mm-hmm.
And it's very convoluted in how they had to wrap all this together and stuff. Because like in 1913, like the Sagnac effect went unanswered for years. It took until 1918 where Paul Lavue had to come up with a special way to to answer the effect. And then that turned out
like
to
the
not
game
even be true.
Mousetrap, It's not even like who stole the cookie jar or who took the cookie and the child has crumbs on its face. It's like you have to go through this loop and then this loop and then down the chute and plop the man in the pan and all that stuff. It's crazy how many assumptions are built on assumptions.
Yeah, man. When I started looking into the Sagnac effect, when I got to that part in my interferometry studies, when I saw that there was like 12 different explanations that they were trying to give for it, and like I was like, oh man, like this is a huge problem for them. They they're just really struggling here to keep it together. So yeah, it was really interesting. Like when you see stuff like that, it's pretty obvious that there's something afoot. So so in 1930, Dayton Miller published his culmination of his 5,200,000 measurements of interferometry, where he was using a classic. He actually inherited Michelson-Morley's device and did a bunch of experiments with that, and he had his own custom device that he built. So the culmination of all his data, though, what he showed was that there's a fluctuation in the speed of light relative to the equinoxes on the day, where the readings reach their minimum and maximum dimensions corresponding to the equinoxes. So when his data is plotted against sidereal time, the fluctuations are shown on the equinoxes, like I said. And then when you plot it against sidereal, when you plot it against diurnal seasonal time, like where you would see like temperature effect variations through the seasons, there's no cause and effect relationship with the variation, meaning that like the apparatus isn't expanding or contracting or anything like that that's causing the fringe shift pattern, because it's like misaligned or something due to the temperature differential from seasonal effects. So
now, these are real scientists. They're trying to disprove what they're seeing in any way possible.
Yep. And keep in mind, so over the course of his career of doing this, like people would make critiques of his work, and then he would follow up and address all those critiques and do experiments, narrowing down the cause and effects, altering all the control variables, really getting the most of that they could out of these readings and figuring out everything. And what he found was that when you do the readings at altitude, you get stronger readings. When you and the correlation with the season, or with the equinoxes, so with what's going on with the sky, I mean, all these effects directly refute special relativity on the face of it, because they show that the variance of the speed of light wasn't the null result in the Michelson-Morley, the way that they need to interpret it, and that removes the justification to transform into another reference frame and adhere to that framework where you're going to say things are contracting and that there's really a larger velocity that was measured, but we just have the smaller velocity. Like this data set measurements and all that completely refutes that. That's why his work is not talked about really. It's not presented as as solid evidence or whatever. And they waited until this man died, and then they published works, saying that he didn't know about temperature differentials and all that, and just all the stuff that his entire career was, refuting and showing. So that's how they refute. That's how they refute him. They just say temperature differentials cause the readings, and there's nothing to see here, boys. Even though, he did this over 30 years, repeated effects. So
yeah,
that's,
wasn't it like millions of times?
5,200,000 on record.
Jeez.
Yep.
That's some dedication right there.
Yeah, the man was very persistent. So we have Pruner and DeFore in 1942, who took the same layout of the Sagnac apparatus. So this just being a circular configuration. And instead of rotating, they just, did the experiment with a circular configuration. And they found that there's a variance in the speed of light. And they were like, hey, what's going on here? Like, relativity says, you should definitely be able to explain this, because relativity can't explain. It does have circular answers for, answers for circular motion and all that. And then in regards to this, Paul Lavue stepped in and tried to answer it. And what he found, or what they found through this, is that relativity couldn't explain, from the reference frame of the center of the apparatus, relativity couldn't explain the variance in the speed of light. And relativity explicitly functions on the facts that it says that at any point in the apparatus, it should be able to derive the relative motion from, and it couldn't do it from the center of the apparatus, which is, a complete failure for the mathematical framework of the theory in that regard. And that does a lot of damage to them saying that the Sagnac effect is due to angular rotation and all that. But they just kind of ignore that and don't talk about it. So we'll just continue believing that the Sagnac effect is due to angular rotation. We'll get back to that here in a minute, though. So we have Yuri Galev in 2002 using radio millimeter waves, reproduced Dayton-Miller's effect, showing that there's a fluctuation in the speed of light corresponding to the equinoxes again, and showing that doing it at altitude, there's an increased effect and all that. Literally reproducing Miller's work. And then he did it again using optical bands a year later, and he has comparisons for the data and all that, and all matches and lines up. So we have repeatable, measurements of this effect of electromagnetic propagation going slightly faster than what they say it should be. So a lot of people will say, what's your natural phenomenon for electromagnetic propagation and all that stuff? So Maxwell's equations and the way that they derive the speed of light and all that, it's all based on those equations, and you're able to get accurate predictions out of that. So when they're predicting things like against the refractive index, and they're able to, predict things accurately and make measurements based on that, it's all based on that. So you shouldn't be weary of like talking about electromagnetic propagation in a way like it hasn't been, like its rate of propagation hasn't been studied extremely well, and that the rate that they give us, that they say, isn't a good approximation for these measurements, right? Now, when they get into the variance, they say that the variance doesn't exist, and that any variance is due to quote unquote relativistic effects where time and space are contracting and dilating and stuff. But overall, like the measurements and the interpretation, is accurate. So there's no need to be afraid of it in that regard, or like have such a rigid view of it and not acknowledge the significance of that, of what those equations represents and how they are used. And so in 2004, Ruyong Wang did one of the so if Michelson-Morely was like the most significant interferometer experiment where they had to change and redefine all of physics to interpret the behavior of light to save the heliocentrism in regards to the motion and how it's detected and the readings and all that, Ruyong Wang in 2004 did another revolutionary experiment with a fiber optic cable. And what he had here was just a fiber optic cable and a set it up in a conveyor belt fashion where the rotating bits would contribute to the fringe shift pattern, and if the interpretation of the Sagnac effect were correct about the rotation contributing to the fringe shift pattern, then the only parts of the fringe shift should be produced by the rotation of this right here and the rotation of this right here. And you can calculate exactly how much this is rotating, so how much this is moving relative to how much this is spinning and all that. So you can get the precise amount predicted that should come out. You can get the exact fringe prediction that should come out of the motion relative to these wheels turning and how much of that angular rotation is contributing to the fringe. Now, also, you can do the same for these linear bits here. And what Ruyang Wang found is that the linear bits also contribute to the full amount of the fringe. So this falsifies the interpretation that the Sagnac effect is due to angular rotation solely. So when they say that Michelson-Gale and the Sagnac effect in inertial navigation systems is measuring the rotation of the Earth, it's not true. This experiment completely falsified that hypothesis, right? And because of the way Wang was changing the orientation of the device and the motion of the device, or I'm sorry, and the backwards motion and forwards and stuff of the cable, provides a counter mechanism to Earth rotation and all that. So you could argue that Wang created a lab reference frame, and meaning that it's actually stationary, and if the effects persist, and that because the effects persisted through that, the natural interpretation is that the Earth is stationary with respect to an ether wind that's affecting the propagation of electromagnetic waves. So this was huge, and this isn't talked about or anything like that, because it directly falsifies the only interpretation that allows a variance in the speed of light within special and general relativity. So to cover the equation real quick, the circular equation that's typically used to derive the Sagnac effect is delta T equals 4 omega A over C squared. What this means here is that the amount of fringe shift produced is equal to 4 times the rotational speed times the area of, so basically the length of light that it has to travel, times the speed of light squared. And then for the linear equation, you have your speed, the fringe shift pattern produced is going to be 2 times the velocity of the area or of the length of the device over the speed of light squared. So what they're doing here, the key factors that they're showing here is that the important thing to note is that motion is what is the contributing factor here, and it's not tied specifically to rotational or just linear, right? So in 2006, Hector Manera set up a classic Michelson-Morely interferometer setup, and they left it running for 3 years. And the data that they collected over that corresponds and backs up Miller's data, showing that there is a speed fluctuation change in electromagnetic propagation relative to the equinoxes, where the readings reach their minimum and maximum dimensions on the peak of the equinoxes. And let's see here. There's one more thing. Okay, so in GPS, Ruyang Wang also points out that so GPS technology also functions on ether, right? So an important thing to note about the ether framework and what an absolute reference frame is, and why all motion is relative to the ether, and what that means exactly is. So let's say hypothetically there's an ether framework, and electromagnetic propagation through that ether is going to be relative to that, and then any motion is going to be relative to the ether. So what that would look like is there would be a delay in the speed of light proportional to the observer's velocity. And how GPS works, it shows that shows that exactly, right? So in the case of a stationary observer and a moving observer, they both have their GPS signal receivers or whatever with them, right? So R1 and R2 right here, and then S1 is going to represent a GPS satellite or tower, doesn't matter, stationary or moving. It sends a signal at the exact moment that the two stationary and moving receivers are intersected, and the distance in reality is the exact same. So the signal and time in which they get the propagation should be the same. But what they find is that there's a variance in the moving receiver, and the variance that he receives the propagation is proportional to his velocity. Now that measurement is taken using a range measurement equation in an ECI reference frame meaning a stationary non-rotating reference frame. And the range measurement equation is basically just, it's based off of a time interval system with GPS time. So all the atomic clocks are synced together. So it's basically just saying a timestamp that says, hey, you sent a signal at this time and the signal was received at this time. What was the difference in the speed of light for that to get there? And it'll be either plus or minus, depending on the direction of propagation and the motion of the observer. And that's a direct contradiction to special relativity, because the postulates upon which the framework is built upon states that all reference frames are equally valid. And the second postulate is that the speed of light is independent of the source, independent of the motion of the source independent of the motion of the source or observer. Sorry, I always get a little tripped up saying that sentence. And so if there's a variance, right, if there's another mechanism facilitating a relative speed, a variance in electromagnetic propagation, that's your ether, right? That's the framework of interpretation. That's why all these people had these frameworks and various interpretations of how the ether might function, because it's an interpretation of real effects, but it's just how to explain it, right, based within the framework that the speed of light should be the same. So let's see. So the ether is the absolute reference frame mathematically, because all motion is relevant or relative to it, and that's especially noted in GPS, where the signal delay is proportional to the velocity of the observer. So the ether wind is the mechanism that provides that, right? So to close out here, we have Ron Hatch, who owns like 27 patents in GPS, has an extensive 40-year career history in GPS, reading from one of the manuals talking about how the speed of the observer, of the GPS signal recipient, right? If they're in motion, that signal has to be accounted for. So we don't have to listen to the audio. I was just going to pull up the slide here. I think this is it right here. So GPS has to include all receiver motion in the effect, rotational or not. So the way that they try and say that the seismic effect applies in GPS is that it's due to Earth rotation, but there's obviously an additional component where it's relative to the velocity of the receiver. So that's what they're noting here in their GPS documents, which is a direct contradiction to relativity theory. And then to end out here, we have Maxwell's equations, so-called, and what Maxwell did to change the equations, right? So the default natural interpretation of electromagnetic propagation has been that there is an etheric framework, and there's a background medium to carry this, for something to wave through, right? To carry this wave, right? So with the original equations we have that explain electrodynamics, you have Ampere's law, Faraday's law, Coulomb's law, and Gauss's law. Now, most of these relate to stationary magnets and stuff like that. So what we're primarily concerned here is Ampere's law and the changes that Maxwell made to that. So Ampere's law originally describes the magnetic field density and its relationship and how it's proportional to the electric charge density of the electric field. And this was experimentally verified as well. And this was the original term to describe all this here. So B, your magnetic field, is going to be equal to that charge potential that's carrying the, the electric current. So that's what that represents here. And then Maxwell added this term here. So this term after the J here is what he added. And what this says is that there's no charge potential necessary for the electric field to induce the magnetic field, and that a magnetic field will just induce it, the magnetic field itself. So to give a visual representation of that, the way that they model out the electromagnetic wave propagation, they say that, there's an oscillating magnetic field and electric current or electric field. So that's what this looks like, the perpendicular relationship to the direction of motion of the current and the and what happens with the electric field. And then there's a counter rotating magnetic field corresponding to that, and that's the right-hand rule. This is what that looks like in a visual representation, right? So at these intersection points here, this would be the static charge potential that's accelerating, that causes and that acceleration of that charge potential is what causes the electric field to induce the magnetic field, and there's no experimental evidence ever just to show that that can happen without an accelerating charge like that, right? And what charges in a vacuum, right? You know, so they say, oh, it's a particle, like that's what this change here is what facilitates the mythology of something propagating in a vacuum where there's no charge potential or anything like that to propagate.
An analogy to kind of make it how absurd this is, to make it sound easier to comprehend how just ridiculous this equation is. Okay, so the pitcher throws the baseball, right? The bat hits the ball and the ball goes flying in the opposite direction over the pitcher's head. What they're saying is you don't need the bat.
Yep.
There is no bat. It's just the ball's going to go flying that way just willy-nilly because. That's how absurd that equation is.
Exactly, bro. That's exactly it. So there's never been a time where there's not an ether framework, right? It's just been obfuscated and we're just told that it doesn't exist when really all electromagnetic wave propagation couldn't exist without it. And it's only through a mathematical reification fallacy that's never been experimentally proven that they even claim that, you know, that this stuff is possible in that regard. And then so for Einstein to come along later in 1905 with the special theory to remove the ether mechanism and all that, really, really just based on nothing, because there's a variance in the speed of those experiments, right? Like that's what that stuff shows. That's what all those experiments show, that there's a variance in the speed, right? So of electromagnetic propagation, and then it's even proportional to the delay, or it's even proportional to the velocity of the observer, right? So that completely falsifies their interpretation. So when they look out in the night sky and they say all this light coming at us in every direction, it doesn't matter. It's all traveling in the same speed. There's no preferred direction. It's all equivalent. Nope, completely falsifies that. They have no mechanism it removes their mechanism to establish, their distances and all that based on their spectral readings and stuff, because they're just assuming that there's no medium interaction and that any interaction is facilitated by their abstract mathematics that describe gravitational fields and the space-time curvature induced by that field. So to close out, I wanted to end on, at the end of the day, we all believe in different things, and that's okay. My buddy Jim Waterworld says that a lot, and just to try to de-escalate tensions between two camps. So if you're not on board with the ether framework and all that, like that's totally okay, but you should definitely consider looking into it, because it's a wealth of knowledge that leads you to a path where you can explain, all these effects in a framework that actually makes sense with a stationary, non-rotating Earth, and you can take away their core quote unquote scientific evidence, right, that they use for heliocentrism. They're just misinterpreting these effects through these experiments, and we could take it back. It's literally this easy to take them back. So highly encourage people to learn about it. And I have a playlist on my channel called The History of Interferometry, where I put a bunch of videos out on this, covering this subject and going in detail and explaining it to give people references for that, and in different sources and stuff. So yeah, definitely look into it. Highly encouraged.
Thanks, Alan. We're going to go over to Rockfin right now, but I wanted to ask you, you said Dayton Miller rewrote his paper or something. What was his conclusions after everything?
Oh, he just did different different statistical analyses of his work, because people were critiquing him on that, and it was all just he was like, okay, well, I'll try it from this angle, and it still supported it. And then Maurice Elias analyzed it and found that it was like his analysis was even more in support of Miller's work, because Miller was overly critical of his work to not be biased or whatever, or to try and reduce bias and all that. And then James Demio also did a review of his work and found that it corresponds to the equinoxes as Miller stated.
Okay, and Zach, you have any questions for Alan, or a way to maybe make this a little bit more palatable to people? I still think we probably left a lot of people. And I'm not sure. Too bad we can't all talk like Austin, but maybe you can summarize it, Alan. I know you're like, I just did. But how could we make it easier for people to grasp the totality of it, and why Michelson-Morely is important, and why dismissing it is dumb. It's an experiment that leads directly to us questioning the current framework, because the current framework obviously skips and takes leaps of logic, they call it, or whatever you want to say, leaps of logic. But really what it comes down to is, according to Feynman and everything I've ever seen about science, is that when you make a hypothesis and then your observation doesn't match, then you need to go back and redo your hypothesis and not start adding things in to make what your hypothesis is correct. Like you're pushing for that hypothesis to be correct, which shouldn't be the case in science at all.
Ever.
Yeah.
Yeah. I mean, what they were looking for was the movement of the Earth around the sun. Should be measurable, right? If it's happening and we have all this advanced technology, even though it was, in the 1900s, late 18 whatevers, they had this advanced technology, and it should have registered it. And if that wasn't advanced enough, the technology we have today should have. It's not like they did this experiment and nobody's done it since. It's
probably the most replicated.
Force, yeah, the Air Force did this back in the late 80s or mid 80s, 85, 86, and they came up with the exact same conclusion, that we are not moving around the sun, and there's this background medium that is swirling around us. And I don't know how many Nobel laureates need to come out and say, yeah, there is an ether. We call it the Higgs field, we call it this, we call it that. I mean, it's kind of sad at this point in the scientific community, where you have all these great minds that can't just man up and say, stop, get some help. This is ridiculous. What are we doing?
And if we,
they want to get paid.
Yeah. And, if you go to, I don't remember what show I did. I'll kind of bring it up in a second as we move over to Rockfin, but talk a little bit more freely. But I did a video showing this guy who's a philosopher of science who basically lays it out. I don't remember his name, but he basically laid it out for us exactly what's going on. And he's even somebody who questions whether or not any of this should be considered science. And I think this is where we all got lost, is that what they do as a children is they teach you the scientific method. And you're like, that seems to be pretty cool. That works. And then they say, well, these things have gone through it. And then science goes through it. And then they just start teaching you science. And so what we all assume is that what they're teaching us as science must have gone through the scientific method, because the definition of pseudoscience is things that are said to be science but don't go through the scientific method. So isn't it peculiar that you start to realize, oh, wait a second, we get to this certain age and you go back looking for evidence which should be abundant, and what you find is the opposite, that it's lacking, that often it's contradictory, that it's mixed in with Lorentz transformations. So now something that's never been observed, any item shortening or changing size or changing because of certain speeds, or we've never seen that, but yet it's cooked into the books. It's already assumed. Dark matter, dark energy, 97% of the known universe has never been observed, which is just what? What do you mean? How do we know? Well, because we assume it must be there, or else our calculations are wrong about these galaxies and these speeds. So we have to have some sort of matter out there. We've got to have some sort of energy out there. I mean, the big one was for me learning that we're not actually seeing the universe expanding. When you hear that, I'm like, oh, so when they look up in the sky, they see things actually moving away from them, which is not what they see. They see red and blue shift, and they apply it as like Doppler effects, and then say that they can calculate how fast something is moving away from us based on its redshift. But again, redshift and Doppler is used when you're talking about an ambulance driving by you, because the ambulance is driving through air, and as the sound comes towards you, it's getting bunched up, and then it reaches you, and then as it moves away from you, it's expanding. The sound is expanding into those waves, so you get different pitches of sound. They apply that to the stars, but the stars don't have any medium. So they're not redshifting Doppler-like. They're not. They're actually probably being simply retarded by the distance that they're traveling, whatever that might be, right? I mean, it could be close, could be far, but we're actually seeing just a reduction. Like, for instance, if they're just a little further than another one, you're going to see it a little bit less. You're going to see it drop off the spectrum a little bit more. But they're, again, assuming something that is completely and totally not observed. And this is where I knew that we had a problem. And again, I always talk about George Ellis, I know, and Edwin Hubble, but George Ellis says a lot of cosmology tries to hide the fact that they have picked their model based on philosophical grounds. That alone should be alarming to anybody who's a real adherent or follower of science, because what it's telling you is that the idea that scientists are unbiased, that they are actually just looking at results and reporting what they see, is not true at all. It's not even remotely true. It means that they've got a model that they've already selected, and so they try and fit everything into that model's box, and it leaves us into a weird structure of the world where right now not a lot of things make sense. Dark matter, dark energy, they just don't jive anymore. And if we would have stuck to real science and scientific method like we've discussed, then and we had real unbiased researchers, then they would look at a result like Michelson-Morley's and they would not try and fix it, which is what Lorentz transformations did. Is they fixed the error that they found. Now, Alan, isn't it true? I know we say that they found a null result, but they did find a speed, correct?
Yeah, they did find a fringe shift pattern, but the original interpretation was that it was an instrumental error and that there was actually no fringe shift pattern, and therefore the speed of light is the same. And then that's when Lorentz came in and was like, hey, maybe there was maybe we can explain this slight fringe through the length contraction mechanism, because prior to the Michelson-Morley experiment, he was doing experiments with electron observations or whatever, and he had already had a framework of this like time dilation contraction mechanism. So that's what he put forward, and they were like, oh, okay, cool, because they still wanted to keep the ether, right? Because there was no reason to abandon it if they could, or if they didn't have to, right? Because it explains electromagnetic propagation very well. And all motion would be relative to it, right? So that would be reflected in their measurements with light. So, yeah.
Okay. Well, I think that, realizing that we are in the default position is, of course, the Earth is stationary, that the Earth does not move, that the Earth is a level topographical with valleys, with mountains, but not 2D. Like, I don't know who thinks that we think that there's actually people who think we think that the world is a 2D. They're like, you don't even understand 3 dimensions. No, we do. We're not saying flat like a piece of paper, okay? What we're saying is that it's not a spherical ball flying through the vacuum of space. But anyway, think of all the things that have been added. They always like to say, oh, Occam's razor, whatever. And then they give you the most convoluted nonsense ever and act like it's science and like it's proven. Speeds going through. You would think that if you're traveling 1.2 million miles per hour through anything that you would know it. And to just have somebody dismiss it with, well, we were born here and that's what, you have the inertia and therefore you don't feel it and you translate these speeds. Okay, great. You can believe that if you want, but just recognize what your beliefs are based off of. They're based off the words of men that could be anything that they want to say. Meaning that tomorrow, if they came back and said, you know what, I know we said we were spinning at this speed or flying around the sun at this speed, but actually it's 13 trillion miles per hour that we're going around the sun.
Okay.
Right. What are you going to do? How are you going to argue if you didn't argue when they said 66,600? How are you going to argue when they say 13 billion?
Well, they just doubled the age of the universe.
Right.
It was 14 billion. Now it's 27 billion.
Right. So, I mean, these are the kind of things that and then it's such a cop-out to be a science believer or adherent to where you feel like you're always right because science goes around and say, oh, well, we always correct things. So to me, it's just a cop-out that these guys just don't want to do much research. It's just easier to believe what science does. It's a comforting position because if you're wrong, all of science is wrong, and so you don't actually look that wrong. Whereas us, if we're wrong, well, we kind of get hung out to dry, right? So this is the problem that we face. Let's go to the other side. If people have questions, we can take questions over there for the next hour, unless we have something else to talk about. But I do want to just hash through this a little bit more and how it resembles the rest of what's going on in the world, that we've been lied to. We've been lied to on a mass level, and now, I mean, those lies are catching up to them. So what happens when somebody lies once, right? They can get away with it. If they lie again, well, they got to cover up that lie too. And then before you know it, these lies start compounding. And we've all dealt with somebody like this in the past that we thought was honest, caught him in one lie. Oh, okay, you kind of give him a pass. And caught him in another one. All right. Third one. All right, hold on a second. Fourth one. fifth one. Okay, now I see what this person's modus operandi is. And we are well past that when it comes to your government, to your media. Once you look into who's financing these things and what things are being played on the media and what they're promoting, you realize it's just another cable TV show looking for ratings, not a source of what's going on in the world. And, the quicker people realize that, stop falling for these tricks. I don't watch the TV anymore. I don't watch the news. I used to watch it in the morning, for 20 minutes or something when I was getting ready. I don't watch it anymore. And I've just noticed that I don't even know what's going on. I hear people all the time say, oh, there are masks here. You got to wear masks here. And COVID. I have no idea because I don't pay attention to that stuff. So really eliminating stuff from your mindset. And I'm a big believer that, when they come out with, the idea of COVID, we'll do that on the other side. We'll talk about that over there. I don't want to get into it here. I'm going to drop the link one more time. Hope to see you guys over there. I don't know how many people we have. Let me check, make sure there's no super chats here. We do appreciate you guys joining as members. I saw Doug joined. I don't know if anybody else did. Oh, what does it say?
I think Justin Johnson, again, gifted 5 memberships.
Justin,
you
are
5.
the best. Let me see up here. I can go like this, I think. Yeah, there. Oops. Wait.
Gift and champ.
I wonder why top chat, live chat. Usually I can see that on here, but I don't see it on. Let me check.
Yeah, usually it'll give you something that says like special chats or something like that.
Yeah, I don't see it today for some reason. And unless there's no super chat, then maybe it only shows on super chats. But it should show on members too. But let me check real quick, and then we'll go over to Rockman. We'll read the tips there if there's any. But let me just make sure that we've got none over here. I don't want to leave anybody behind. 1 second. And I guess you could just tell everybody that's on YouTube what's coming up for you, Zach, this week.
Yeah, I have the map out on Fortnite to where anybody can play it now. It's not released like on the Discover page yet. It's only for people in the know. So I put something up on my channel with the island code. Anybody who plays the game will know what that is. And then I shared it on GLOBEBUSTERS. So there's already been a few people that have jumped on, and I've gotten some good feedback so far. Having some problems with the player spawners, getting them to spawn in the right spot and stuff like that. So we're still working out the kinks and bugs with more players. But if you go to my channel or just jump into look up on GLOBEBUSTERS, go look in their community, and you can get the island code and just go check out the Flat Earth on Fortnite.
Awesome. I want to... go ahead.
I was going to say, I will be going live probably next week, maybe Wednesday. And I wanted to get a group of people together and just kind of show off the map live and see if we can get some more people to jump in and join us.
Sweet. And just a big thank you
for that.
Big thank you to everybody who's joined as a channel member. I think we'll come up with something eventually to do for those people, whether it's a special stream once a month or something. But I'll just read through these names real quick because I want to say thank you to Mother Dragon, Nick, Angela Baby Carson. Thank you, Angela. Dr. Bass Ackwards, Martin Haley, Doug Maurer, Fungamungus, thank you, Mike Bowl, Ether, Plain Reality, Mr. Jones, Nate Montgomery, Riley, Karen B, Adam, Passing Through 7x3, Maxine, Troubling Tribune, What a World, Atlantis, Sun City, Cindy J, Nemo, Tiffany Vici, Auditing Reality, Brenda Debates. Brenda Debates is a member of GLOBEBUSTERS. Thanks, Brenda. VMDAS, Alternate World, Dysfunctional, what is that? Dysfunctional Navi. I don't know. It's not giving me the rest of the name. Adam, AE0, Good Times for All. Zach, thank you very much. Shift, Space Miner, Mellowdome, Mr. One, Question the Answers, Clearview, Angle of Elevation, Lee Redpath, One Neo, Anson Howard, Kevin DeShill, FE Nation, Rethink Inc., Mario C., Saddlebum, Killer Man Kakuzu, Commercial Sound and Video, Creature, Callaway Crusher, Napper Tandy, Rebecca Borbola, Nephilim Slayer, Stephanie, John Sopko, Mark Allen, MFT, Brianna Lynn, thank you, Brianna, Sander, Flat Sabbath, thank you, Flat Sabbath, Undoctrinated with Ryan in there, Undoctrinated, Lord Racer, Unveiling This Realm, Aisling, thank you very much, Cami, for your support of the channel, and Justin Johnson, who's likes to hand out memberships, and we do greatly appreciate it. So we're going over to Rockfin. Thank you guys for being here on YouTube, but we'll go over there. We can talk freely and take some calls for the next hour. Remind you guys, please, to not lie to each other and be good to each other. Open your mind. There is truth inside. We will see you Thursday here on the GLOBEBUSTERS channel for tech, and then next Sunday again back with another fantastic Sunday show. Until then, we'll be over at Rockfin. Join us. It's free while the show is live, and you don't even need a membership unless you want to, or you don't even need an account unless you want to chat, in which case just sign up for a free account. And we will see you guys soon. Thank you very much. Until then, peace.
Peace.
All right, so we are done at the YouTubes.